So the 2014 AP Calculus AB question 4 tells us that train A runs back and forth on an east-west section of a railroad track. Train A's velocity measured in meters per minute is given by a differentiable function VA of t, where time t is measured in minutes. Selected values for VA t are given in the table above. And then as we can see, we have our table which has time in minutes and our function with respect to time in meters per minute. And then we have the following numbers and values given. Part A is asking us to find the average acceleration of train A over the interval 2 to 8 minutes. So what we're going to actually want to do here is, this to me sounds a lot like average rate of change. So average rate of change. So we know that that formula actually looks like this, which is it's f of b minus f of a, and then that's going to be divided by b minus a. So at that point we can actually just plug in our numbers. So this is actually a pretty easy question. So all we're going to do is do 120. So we're actually going to do negative 120. Sorry about that. So minus, and then we're going to subtract our 100 under the 2 value, and then we're going to divide that all by 8 minus 2. And that itself will get us negative 220 over 6. And that itself can be simplified to get us negative 110 over 3, which will be our simplest form for this question. And then at that point we're just going to put our units, so it'll be in meters per minutes squared. So there we go. And that will get us our average acceleration for this problem. Part B, the question asks us, do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some point, at some time t, within 5 minutes and 8 minutes? And then it says give a reason for your answer. So actually this is a pretty easy question as well. So we know that in the given information that we have, we know that v of a, which is our function, is differentiable, which means that v of a is also continuous. So knowing this information actually allows us to solve the entire problem, because we know that from 5 minutes to 8 minutes we start at 40 meters per minute, and we go from there to negative 120. So I'm going to write that a little bit more obviously. So negative 120, negative. So if we're going to go from 40 to 120, and there is no stops between there, or no way that we can cross from one point to the other, and if it's continuous, that means that at one point that 40 is going to be a 41. Actually, sorry, it's actually going to be 39, and then 38, and then 37, and so on and so forth until we get to negative 100. And then from there, it'll get us to eventually negative 120. So knowing that, we know that this is continuous. And likewise, if you actually kind of read the question, it says train A runs back and forth on an east to west section of railroad track. And kind of for some context and reasoning for your answer, you could say that obviously the function is continuous because it's differentiable. That's our mathematical approach, but we can also kind of look at it and think of it kind of from a logical point of view and say, well, a railroad, you can only go one way and another way, so you can't stop and take the train off the tracks and then put it back on later. You're always on the tracks no matter what. So it's kind of a good thing to know. So we know that at the end of the day, we're going to get from 40 to negative 100 and then eventually negative 120. So that's how you solve part B. It's pretty simple.
Hello, my name is Meredith Angeles, and I'll be going over part C and D of the Calculus AB 2014 FRQ number 4. So part A is saying using trapezoidal sum with 3 subintervals indicated by the table, approximate the position of the train at t equals 12. So first thing we're going to do is let x of t, which is position, be A's position at time, which is t. So we are trying to find the position at 12 seconds, t equals 12. So how we're going to do that by using the given position at 2 seconds, which is 300, plus the integral from 2 to 12, which is the area under the curve, and we're integrating velocity, which is v sub a of t dt, because the integral of velocity is position, which is x of t. So now we're just going to substitute in our numbers and solve for what x of 12 roughly is. Since it's asking us to use trapezoidal sums, we're going to have to use the formula for an area of a trapezoid, which is base 1 plus base 2 times height over 2, which is why we're multiplying by 1/2. So our final answer will roughly be x position at 12 seconds will be negative 150 meters. So part D is saying a second train, train B, travels north from the origin station. At time t, the velocity of train B is given by v sub b t equals negative 5t squared plus 60t plus 25. And at time t equals 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between train A and train B is changing at time equals 2. So in this situation, I put x sub a to represent train A and y to represent train B. So we just found out that train B is going north. In part C, we know that train A is going east. So that's going to create a right angle. And because of that, we can make a right triangle and find the rate from, we can find the rate of z. So we're going to use the Pythagorean theorem, which is normally a squared plus b squared equals c squared, but in this case we're going to substitute those for the variables that we are using, which is x sub a squared plus y squared equals z squared. And so since Pythagorean theorem is going to tell us position and not velocity or rate, which is what we're trying to solve, we're going to find the derivative of that, because the derivative of position is velocity. So here is the derivative of the Pythagorean theorem, which is 2x sub a times velocity sub a, because the derivative of x sub a is going to be v sub a, which is velocity, because x is the position, but now we're trying to find velocity, plus 2y times v sub b, which is the same principle that we used for x sub a. And then equals 2z, and then when we find a derivative of something, it's normally dx over dy, but in this case, we're trying to find dz. And since everything is in time, in relation to time, we're using dt. So now we're going to have to substitute a lot and find a lot of values. So we already know the first half or so of the values that we need to substitute. So 2 times 300, which was given to us, 300 is x sub a, and that was already given to us earlier in the problem, times 100. And since we're finding it at 2 minutes, we're going to use our table, which says at 2 minutes, it's going 100 meters per minute. So we're going to substitute that in, plus 2 times 400, which is given to us right now in part D. And now we're trying to find v sub b. So they didn't give us a value for v sub b, but they did give us an equation. So we're going to substitute 2 for t, but the original equation is negative 5t squared plus 60t plus 25. And we're going to substitute 2 in for t because that is the minutes that they want us to find. That's minutes they want us to find. And then once we substitute, we'll find that v sub b is 125. So we're going to plug that in, and then we're going to put 2, and now we need to find z. So we didn't get a value for z either, but we do know the formula for Pythagorean theorem, which is x sub a squared plus y squared equals z squared. And so we're just going to plug in 300 plus 400 squared, and then we're going to get that equals roughly 500 squared. And when you find the square root of that, you're going to find that z equals 500. So once you plug everything in, you're going to solve for dz dt, which is the rate that we're trying to find, and we'll get that the rate at 2 minutes is equal 160 meters per minute.
So I'd like to thank Meredith for helping out with the video, and also like to announce the subscriber giveaway winner, which is Aaron Rudd. So congratulations, and I will message your account soon. So thank you for watching, and subscribe for more content.